Hello, good evening, or good morning, or good afternoon, whatever. Today we are going to have the most awesome time of our lives when we get through some questions for your WAEC, especially as it concerns mathematics. If you look at the board, you have questions as it concerns most of the things you have to do in your mathematics. For today, we are going to look at some things that we could solve, and you also assured that you are going to be given exact lessons that are clean, clear, understandable, and everything that you can think about it. Well, of course, mathematics is something that is fun for those who wish to consider it that way. So today we have a WAEC class, and I want to thank especially the Obese family, because this class was meant especially for them. I want to especially tag Uche, who is also going to be at least the first person to take advantage of this opportunity. So for the first class that we have today, we have what you have on the board. So I'm very sure that you can see it. I hope you can see it. It's very clear. Very good. And I got a black marker that could make it easier to see and very easy to read. So the first question we have says, find the volume of a cone of radius 3.5 centimeter and vertical height 12 centimeter. Now if you look down there, not to also forget that it said take pi as 22/7. Now pi is always considered when you have a circle in a shape. It's either you have a circle itself or you have a circle in a shape. So if we are talking about a cone, you know that a cone has a circular base. A cylinder also has two circles, one on the base, the one on top. So as long as the shape has a circle in it, you must consider pi is a constant. Alright, let's head to the solution proper. I have drawn the shape of a cone, and I've also fixed in some of the sides so that you get to know where to fix it in. And also I've given you the formula, the standard formula for finding the volume of a cone. Now if you look at that, you have 1/3 pi r square h. 1/3 pi r square h. Now if you look at this, pi r square, what does it remind you of? If you say area of a circle, then you are very correct. Now if you look at that too, do you see that a cone has an interior height, a vertical interior height that drags from the apex here down to the base, down to the center of the circle or the circular base? So it has a height. So we're talking about the area. So it has a height on the area. It has a radius, which is half of the circle, the circular base. Now, this particular cone is 1/3 of the area of a circle. It takes 1/3 of the area of a circle, but also to consider that it has the height. So that is the reason why we have the formula in this manner. I just hope it's clear that way. Also notice that there's a perpendicular line drawn from the point here, that apex, down, or the vertex, down to the center of the circular base, which forms 90 degrees to the base. So with the question we have, can you identify the parameters involved? let's write out the parameters. Check out that the parameters you have are in this manner. So we are looking for volume. So volume, or V, is unknown. So I'm going to check that out by putting a question mark to show that it is unknown. Another parameter we have is radius. Our radius is 3.5 centimeters, and the vertical height, which, of course, the reason why it is specified that it is a vertical height is because you also have a slant height. You have a slant height and you have a vertical height. So most times vertical height is indicated as H, but your slant height is indicated as L. So L represents your slant height, but in this case we do not consider L entirely. Alright, now having considered these parameters, do you notice that we already have pi? Pi is given, the radius is given, the height is given. So it's very easy to work with volume as the unknown. So let's apply that. So this implies that V is equal to 1 over 3. So we are substituting now. Pi is 22 over 7 times R. R we have 3.5 squared times height, which is being 12, right? So I prefer to put over 1 in all of them. Sorry, this is 3.5, not 3.7. 3.5 squared. So V is giving us whatever we'll get when we cancel out. So notice that 3.5 squared, what would 3.5 times 3.5 give us? So let's see. 3.5, so I'm going to find that out by multiplying both of. So 5 times 5 is 25, carry 2. 5 times 3, 15, plus 2, 17. So there's no need for this for now. Remember, you're multiplying. So 3 times 5, 15, 5, carry 1. 3 times 3, 9, plus 1, 10. So you're having 5, 7 plus 5 is 12. Carry 1. 1 plus 1, 2, then you have 1. So what do we have? 2 decimal places, 1, 2. So you have 12.25. So the reason I had to find this out is for you not to make the mistake of thinking that this, you are adding this. If you add this, you will get 7. So don't make the mistake of cancelling out at this point. So okay, because what we are getting is 12.25. It is not 7, because if you add 3.5, again, that is 3.5 plus 3.5, you're definitely going to get 7. But now, instead of working on that, I think we'll have a common factor that could go into both of them. So I'm having 3 here as 1, 3 here as 4. Notice that we have only 7 as a denominator for all the fractions that you have there. So now, having done that, we are going to have 22 times 3.5 squared times 4 over 7 left. I hope you are seeing that. So you have that V is whatever you get by getting this thing all through. So if you multiply everything, you are going to get 1078 over 7. 1078 over 7. I hope you saw that. 1000. Alright, so now we need to cancel out. So 7 into itself is 1. 7 into 10 is 1. Remember 3. The closest multiple of 7 to 37 is 35. And the factor is 5. And that will remain 2. So you have 4 there. So our answer is 144 centimeter cube. Now why do we have cube? Because anytime you are dealing with volume, you must have cube by the side. So even if you are dealing with volume of a square, volume of a cylinder, volume of any shape entirely, you must have that cube, that power 3 on the unit. So it gives you that proof that what you are working for is volume. I hope it's very clear, because if you don't do that, you've already failed. Now, why do we know that? Take for instance, 100 represents 100, right? Of course, it represents 100. But once you say 100,000, that becomes 100,000, right? Or if you say 100 million, it becomes 100 million. So the unit to any figure changes it entirely. So the unit to any figure, as it concerns shapes, so when you say centimeter cube for length, of course centimeter has to do with length, so it also changes because of what you've added. So once you are working with volume, you must make sure that you add cube by the side. So take a look at what we have here. We had just discussed volume of a cone, but this one is different. This is volume of a cylinder. Volume of a cylinder. Now notice that it is different from volume of a cone. For a cylinder, of course, like I told you, it has two circles. But what is being considered is the height and the radius. Notice that there are two of them. Then you have your height and your pi as well. So this formula goes for volume of a cylinder: pi r squared, meaning r times r times height. So you can multiply all of them all together, you get what you want. We hope that along the line that we're going to get questions that has to do with some of these things. But in the meantime, let's go on with some of the questions that we have in our WAEC. So if we look at the board, we have a different question, and it has to do with probability. And it says the table gives the scores of a group of students in an English language test. Then you have the scores. You have the scores 2, 3, 4, 5, 6, and 7. Then you have number of students. You have 2, 4, 7, 2, 3, 2. Now, if a student is chosen at random from the group, what is the probability that he scored at least 6 marks? So some of the key words to look at is at random and at least. So that is a basic thing to look at. Now, what do you mean when you say at random? At random means you are choosing without being careful. You just pick without looking. Picking without being careful. Just pick anything that your hands get to. So it's not, you don't have a particular thing in mind, you just want to pick. You know very well that if it was that you were looking at the probably when you have something like a bucket filled with different colors of a particular fruit, or a box filled with different denominations of money, if you shut your eyes and pick any money, you are not going to be sure of what you have picked. You are picking at random. So with your eyes closed and you are looking at the box, you won't know what you have picked. You are picking at random until you look at it. So that's what you have. That's the different thing here. At random. From the group, what is the probability that he scored at least 6 marks? Now I want to also emphasize on this word, at least. So you have two things. Let's emphasize them. You have at least and at most. What is the difference? Now I like to explain this thing using this logic. So you come to a house, and maybe in your own families. Now, how many children are in your own family? How many siblings do you have? Maybe 2, maybe 3, maybe 4 or 5. But I know in your own family you may have like 2 siblings, or maybe 3 or 4. So let's imagine that in a family you have 4. So if you have 4 kids and your parents have decided that they are probably going to give birth to another child, at the moment they have 4, but they can still give birth to another child. So you could say that in that family, since there is hope that you can have another child, then in that household you have at least 4 children, because there is still hope for more. But you cannot have below 4 and it stops there. At least 4 more are coming. But when you talk about at most 4, what you are saying is your parents have stopped giving birth. Maybe all the children you have in the house have become adults. So your parents are old, they are aged, they are elderly, so they are not going to have any more kids. So you can talk about at most 4 kids. So that's the end. 4 children. I hope it's clear that way. So with that analogy in mind, having at least 6 marks means you could have 7, you could have 8, you could have 9, but you cannot have below 6. That is the idea. You cannot have below 6, but you can have above 6. But if it says at most 6, you cannot have above 6, but you can have below 6. I hope it's very clear that way. So that is the difference between when you say at most or at least. So let's get to the solution proper. Before I dive into this, I would love to explain further the idea of probability and how it affects whatever you do. So talking heavily about what probability actually stands for, we're looking at when you say for those who are very spiritual and they want to start talking about what the Bible says about probability. Well, as Bible students, we know that the Bible at times said, probably you may be concealed in the day of Jehovah's anger. Mark the word probably. So which means you are guessing, but now it is an accurate guess in some way, because you are working with facts that you are saying. It's not like you're just guessing without facts. People speak of constructive argument because you are talking with facts. So probability does not mean you are just guessing without facts. You are guessing with the facts on ground. That's the reason why it becomes something mathematical. So probability actually, just like you have on the board, is the likelihood of an event happening with a number of facts you have. You have already attempted some things. You have made some attempts. So by the time you've tried the first, the second, the third, the fourth, you are getting an average score. Then you can make your inferences. So probability actually is talking about, for mathematics, for the whole mathematics, so you have likelihood of one or more events occurring divided by the number of possible outcomes. Then you have what you have. So total number of events over number of possible outcomes. That is what you have as your probability formula. But in the event that you're having multiple events, so what will you do? So it's time to break them into smaller pieces. break them into smaller chunks that you can handle, and after doing that, multiply the separate likelihoods by one another. That is just the thing. Break them into smaller chunks and multiply the separate likelihoods by one another. So let's look at how to apply this in this further explanations. What are some things that we might see in the process of learning probability? So let's look at the first way to solve probability. So when you have what is called mutually exclusive outcomes. Mutually exclusive outcomes. Now, what does that mean? When something is said to be mutually exclusive outcomes, well, let it not sound as very big a grammar for you. When something is mutual and something is exclusive, let me still use example as Bible students to explain what you mean when you say exclusive. When the Bible says you are giving Jehovah exclusive devotion, what does that mean? You are worshiping only God. There is no other thing that is competing God's time or God's worship with the worship you are giving. No other thing. No God, nothing whatsoever. So it's exclusive to Him. So mutually. So even when other outcomes are there, that at that particular moment in time, you could only have it. So that's what mutually exclusive outcome means. But let's break it down. The first way to calculate probability, like we said, is to choose a mutually exclusive outcome. Now, to calculate probability, you have to make sure that it's either the event is happening or it's not happening. So you cannot have the event and the opposite of the event happening at the same time. Of course, we have looked at certain examples. We have looked at rolling a 4 on a die. We know what a die is. For those who play Ludo a lot, once you throw a Ludo or you throw that die, you can only have a number on top, showing on top. You cannot have the 2 numbers or 3 numbers showing on top. It's not possible. So one number must show on top. And when it shows 4, it cannot at the same time show 3. It cannot at the same time show 5. It cannot at the same time show 6 or 1. It can only show 4 at a time. So that is what that could also mean. Well, I use the case of dogs racing. If you have a dog, well, of course, in this side of the country, you really may not have dogs racing. So if you have such a thing, it is only one dog, that same dog, and once he wins that race, he cannot win and lose at the same time. It happens nowhere. It is also, what is the probability that you have gone to the Kingdom Hall to have your meetings? It's either you are there or not. And when you have gotten there, you cannot be at the Kingdom Hall and also be at the house. You can't do that. It's either those who are married or not. So you cannot be married and be single at the same time. So there are things. You cannot be a boy and at the same time be a girl at the same time. No, it does not work anywhere. So that is what you mean when you say mutually exclusive outcome. The outcome or the result of the attempt is going to be particular to that thing or to that person or to that event. It is not shared with the opposite of that event for any reason. So that is what it means to solve a probability when you have something like this. So I'm very glad that you are still sticking around. So the second way to solve or calculate probability is by defining all possible events and outcomes that can occur. So let me ask you something. In a die, how many outcomes can you find in a die? So you can actually either have 1, 2, 3, 4, 5, or 6. So you can have any of the 6 numbers. Those are the outcomes. But you have one single number that you desire. You might desire 3. You might desire 4. Or you might even desire 6 in itself. So in that case, if you are desiring 3, according to what you have on the board, 3 is the event. And we know that a 6-sided die can land on any of the 6 numbers. So the number of outcomes are how many now? Just 6. So we have 6 possible events and 1 outcome. So having said that, so we're having 1/6, which is event, which was gotten by event over possible outcome. So this is the second way of solving probability. Now let's look at the third way. So if we can continue, so you have a third way that you can solve probability, and what you have is divide the number of events by the number of possible outcomes. This will give us the probability of a single event occurring. So let's look at the case of rolling a die, or rolling a 3 on a die. The number of events is 1 because you only have 1 3 on a die, and number of outcomes is 6 because you can either have your 1, your 2, your 3, your 4, your 5, or your 6. So you can either have 6 of these numbers on a die. So because you can do that, you can express it through a relation or a fraction. So the 1 here represents the event, while the 6 is the possible outcomes. So the event meaning what you are looking for at the moment, what you intend to find at the moment. So that's what we are looking at. So this is a third way. Now let's look at the fourth way. So if you look at the board, we have another way by which you can represent probability, and this way it means add up all possible event likelihoods to make them equal to 1. So add all possible events to make them equal to 1. So that's what we have. So if you look up at the board, you notice that when you say 100% of anything, it means 100%. If you remember when I explained earlier, 100% actually means 0. Actually means everything. It means total, it means sum, it means all of it. For instance, if you likely want to go and take a loaf of bread in the fridge, and let's imagine that that loaf of bread has 12 slices. If when you bought it from the supermarket, how many slices were in it, wrapped, packaged? How many slices? They were 12, right? Good. So if you have 12 slices complete in a well packaged bread loaf, we're talking about how many? In percentage, it is what? 100% of the bread. But when you get to the fridge and you notice that instead of having 12 loaves, which is 100% of the loaf, 6 of the slices have been taken, which is half of the total. So in percentage, how many do you now have left? How many? If you answered 50%, you are correct. So when you speak of 100%, here it says the likelihood of all possible events needs to add up to 1 or to 100%. So if the likelihood of all possible events does not add up to 100%, it means there's a mistake somewhere. There's something that is missing. There's something you did not add or include. So for example, rolling a 3 on a die will give you 1/6. How do we know that? The number of possible outcomes is 6. The event we are looking for is what? 3. And how many 3s do you have on a die? You just have 1, so it's 1/6. But the likelihood of rolling all five other numbers is also 1 over 6. So each of them is 1 over 6, 1 over 6, 1 over 6, 1 over 6, which will give you 100%. This is one thing to also consider. Now let's look at another thing to consider when calculating probability. So another thing to consider is representing the probability of an impossible outcome with a 0. This is very crucial, because what this means is that there is no chance of that event occurring. So anytime you are working with an event that cannot occur, just represent it with a 0. We have an example here. What is the probability of commemorating Jesus' death? Here it says, what is the probability of celebrating Jesus' death before sundown? Of course, the probability is 0. Yes, it is 0. And why do we say that? Because it is not possible. So that is why we can represent it as what? As 0. So these are 5 things, major things to consider while working with probability. So the student is chosen at random from the group. If you remember that question that we solved, the child is chosen at random from the group. What is the probability that he scored at least 6 marks? Probability for at least 6 marks. So let's put down our solution here. Let's put down our solution. Now, according to, if you go back to that diagram that you drew, that same diagram that you drew, that you had scores, you had a section for scores, and you had 2, 3, 4, 5, 6, 7. The number of students, you had 2, 4, 7, 2, 3, and 2. Now, if a student is chosen at random from the group, you are choosing a student from the group, what is the probability that he scored at least 6 marks? At least 6 marks. In the scores, when you check, remember the explanation about at least 6 marks. So 6 marks, we are talking about 6 and 7. If you remember, it is 6 and 7. So the number of possible outcomes, you have 6 and 7. So you're having event over number of possible outcomes. So according to what you have, they said if a student is chosen at random from the group, what is the probability that he scored at least 6 marks? Now notice that the 6 marks lies between 3 and 2. The last scores you have there are 6 and 7, and they lie between 3 and 2. So we have things like, if you look at the number of students that we have, the number of possible outcomes that we have is the total of all the students there. So you have 2 plus 4 plus 7 plus 2 plus 3 plus 2. So let's add them together. 2 plus 4 is what? 6, right? 6 plus 7 is 13. 13 plus 2 is 15. 15 plus 3, 18. And 18 plus 2 is 20. So number of possible outcomes, you have 20 of them. Now, how many students scored 6 and 7? So we have 3 plus 2. So we have 3 plus 2, which is 5 over 20, which at the end, if you divide 5 here 1, 5 here 4, you have 1 over 4, which becomes our final answer. So it's as simple as that. It's not difficult. It's just for you to look at it and know what best works for you. So we are having the hope that we can have more of these questions coming up, and the applications, and also with the explanations that you are being given, the explanations on probability. So not to forget that, let's have a recap of what we need to calculate probability properly. Let's have a recap of what we need. So remember, we made mention of making sure that you have the number of possible outcomes with the event on top. That is always very important. You also remember that the last thing we said was make sure that impossible outcomes are represented as 0. Those are very crucial to getting probability. So I'm very sure that you must have gathered some things that would help you in your conversation around probability. I am also very hopeful that we'll have further classes. So it is important that you click on the subscribe button that you have below there and subscribe to my YouTube channel, because we are going to use this platform to do a lot of things, especially as it concerns calculations and whatever things that we have that has to do with my own intellectual capacity or intellect. So thank you very much for being a part of this class. Uche, I really appreciate you for keeping up to date. We hope that by in no time that we're also going to make videos for other subjects or other topics. So all you need to do is to key in and take advantage of it. We are sorry that it has to be this way, but I think it's making sense for the fact that we are in a very hard time for humans globally, where people are trying to adjust to life online, and it's not been easy. It's not that funds are really coming in that much, but we have to move on with our lives and ensure that the basic things of life, especially as it concerns education, does not stop. So let there always be a platform where you can go and gather your educational development. And so this is one of such platforms, and we hope that you will benefit maximally from it. So thank you for your time, and we hope that you will look at some questions on probability and also solve them yourself. So let's find out some of these questions and see how you also can take advantage of it and solve them yourself. So this is what we have at the moment. So you might do well to pause and play to take down whatever question you want to take down. So it's important to acknowledge that this number 2 might be a little trickish for you, but all you need to do is to get it done, and let's see how it will play out. There are other things to know about probability, but at this moment this is like what you need to do what you can. You could also go through your past questions and see some other questions on probability and get to solve them. So I really appreciate your time and the way you have been with us throughout this program, and we hope to have more with you when the time comes. So have a lovely evening, have a lovely time, and I look forward to seeing you in our next class. Please don't forget to click the subscribe button down there on your YouTube handle. Just click on the subscribe button. It's important, because so that you could always be informed about whatever activities that we have on this platform. So thank you very much, and cheers. Take care.